Today we're going to take a look at linear programming. Linear programming allows you to find a maximum or a minimum of a function. The maximums and the minimums will come at the corner points, the vertices of what we call a feasible region. Your feasible region is what you get when you graph a system of inequalities like we have over here. When you graph those and you're looking at the overlapping region, that's your feasible region. Now, we have our feasible region over here in green. But let's review how to come up with this feasible region. If you're looking at y or x is less than or equal to 5, you know that x equals 5 is a vertical line. So you would do a vertical line right here. Since it's x is less than 5, that means you're going to be shading over here to the left. So, shading over here. Now, when you look at the next one of y less than or equal to 4, you know y equals 4 is a horizontal line. So that's what we have right here in red is a horizontal line. Y is less than, so that means you need to shade below. So I'm going to shade below that horizontal line. Then we have our bottom one. A lot of times I like to go ahead and use the idea of your slope and your y-intercept. So if you solve it for y, you get this. So you know you're going to cross at 2, have a slope of -1. So you're going to cross at 2, slope of -1, so you go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on. So that's how you get the blue diagonal line. You're looking for y is greater than that, or equal to. So that means you need to shade above that, the blue line. So if you're looking at where all three of them overlap, it only ends up being this green area. You then want to go ahead and find your corner points. In this case, it's pretty easy to find our corner points just from looking at our graph. That's why it's important to try to do an accurate graph. So you may want to be using graph paper. So you have your corner points, and then we have our function. Our function's given to us up here in our problem. And so that's what we have right here. So now all we're going to do is take our x value, plug it in, our y value, plug it in, and then we're going to go ahead and simplify that, a -6 minus 8. Do the same thing for the next point. Plug it in for our x and our y into our function right here, simplify, and do that for the last point. Plugging in your x and your y, simplifying it. You're now wanting to try to find the maximum and the minimum. Well, this one here is hooked up to the 21, so you know that that's the maximum. Your minimum of these three numbers is your -14, so you know that's your minimum. And this one here is nothing. With linear programming, you want to first of all figure out what your variables are. From the word problem, you want to go ahead and write your system of inequalities. You then want to graph it. You want to find your vertices of your feasible region, so that's the corner points of the region that is formed. You want to have your function that you want to maximize or minimize, which typically comes from your word problem. You then want to substitute your coordinates from your vertices in number 4 into your max and min, just like we were doing on the last problem. And then you want to find the ordered pair that's either the maximum or the minimum, depending upon your function. So let's take a look at this problem here. Go ahead and pause it and read through the problem. Well, we're going ahead and we're looking for number of lawns to be mowed and number of pruning of shrubs that should be done. Those are the two things we don't know. So we're going to let M be the mowing of the lawns, P being the pruning of the shrubs. Now, we know that we can't have M and P being negative because you can't have a negative number of jobs. So M and P both have to be greater than or equal to 0. A lot of times your variables will have to always be greater than or equal to 0. But you need to always look in the context of your problem. So most of the time you'll have these two basic inequalities. Now, if you look up here in the gray, no more than 2 pruning jobs. So P is for your pruning jobs. You can't be more than 2, so that means P has to be less than or equal to 2. Now, let's look up here. We know we have a maximum of 9 hours. So if we look at our hours, we know our hours has to be less than or equal to 9. Well, we know it's 1 hour for your mowing job and 3 hours for your pruning jobs. So we're going to have our 1 hour times the pruning jobs. That's our 1 times our M. Plus you got to have your 3 hours times your P for your pruning jobs. And that has to be less than or equal to 9. Now here I'm just going ahead and solving it for P. I'm solving it for P because over here on my graph I have P as being my vertical axis. Normally we go ahead and solve it for Y. That's your vertical axis. So here I'm solving it for P. Now I can go ahead and graph this. The first two, M is greater than or equal to P, or 0, and P is greater than or equal to 0, puts you just basically in the first quadrant. Now, P being less than or equal to 2, remember P is like our Y. That's going to be a horizontal line. Less than means you're going to shade below. Over here, we know we're going to start at 3. Your slope is negative 1/3, so you're going to go down 1 over 3, down 1 over 3, down 1 over 3. Less than, so you got to shade below. So that's why we're shading down here. This is our feasible region. Then you can go ahead and find your corner points. So you have this corner point, this corner point, this corner point, and then we have our corner point over here. Now, we're trying to go ahead and maximize our income according to what the problem says. To maximize our income, it says our income, we get $40 for each lawn mowed. So for each lawn mowed, you gotta multiply that by 40, plus it's 120 for each pruning job. So all we want to do then is take our corner points, plug that into our function right here. So we have our corner points. Well, the first one should be obvious. If you do no work, you're not going to get any income. Here you have 0 mowing jobs, 2 pruning jobs. So you plug in 0 for M, 2 for P. Plug your 2 in for M or P and your 3 in for M. And plug in your 9 for your mowing jobs. So we end up getting this. And once again, the problem stated that we were trying to maximize. So we're looking for the maximum. Well, in this case, if you're looking at the maximum, we actually have 2 situations. So you really have 2 different answers. Most of the time, there'll only be 1 maximum or 1 minimum. So you could have the first situation where you have 3 mowing jobs and 2 pruning jobs. That's what we're saying here. Or you could have the last situation, which is just 9 mowing jobs.